Hi everyone, so welcome back to my YouTube channel, and today I'm gonna talk about one of the very important concept, right? From the random variable. Okay, so today we are going to see that we can use one of the very important concept called symmetry. Can employ symmetry concept on the random variable process. So you can solve many questions. Already has been asked in the gate examination or might be asked in. So we'll talk about symmetric concept, right? Uh, from your conventional approach, you can better go for symmetry. Okay. In what cases, what situation you can go for symmetry? Those things I'm gonna talk. So I hope my voice is audible and everything is okay. So yes. So you can see here the concept, right? I'm just gonna talk about the concept that is symmetry. Symmetry concept is very important, and where we can employ these concepts, right? So after Teachers Day, just I am conducting this. So I hope your preparation might be going well, right? So situation will be like this. Suppose situation is like this. Suppose you have got two random variable x1 and x2, right? And x1 and x2, right? And they have got the uniform density. They have got uniform distribution. You can say they are uniformly distributed between 1 and 0. Okay. So you have got two random variable x1 and x2, right? And they have got the uniform distribution, that is 0 and 1. Or you call it x1 and x2 are IID process. You can say, they are identical and they are independent as well, right? So x1 and x2 are, independent, right? Dependent and identical. If these two conditions are met, okay, so you can employ symmetry condition here, right? So you can also call it IID process. Okay, so you can say x1 and x2 are IID. Okay, IID, okay, independent identical distribution. So from this question can be asked, okay, or already has been asked in your gate examination, right? So what kind of question we can ask from if x1 and x2 are IID process? Okay, I mean independent and identical distribution is given, right? Then question can be asked, what is the probability that x1 is greater than x2? If they will ask you what is the probability that x1 is greater than x2, so in this case you can use the symmetric concept, right? You can whether you can use symmetric concept or you can also go for double integration, but I think double integration is going to be slightly challenging. Okay, I mean you can also solve this question with the help of double integration because there are two random variables. Okay, and you can use so first of all, what I will do here is I will draw the region of support. So let me draw the region of support, right, for this problem. Let me draw here the region of support. And you see how I'm going to use the symmetry. So region of support is going to be like this because your, this is, you can say this one and this is x2. This is what the IID, that is distribution given, uniform distribution, is distributed between 0 and 1, is also 1. So what you can do here is you can plot the region of support, right? So what they are asking is they are asking probability of x1 greater than x2. You can what is the no, x1 equal to x2 line, that is going to be this. So this is what the x1 greater than x2, right? This region, understand, this region is greater than x2, x1 is, and if they will ask you what is the probability that x2 is greater than x1, so again the same region of support, this is going to be the x2 greater than x1. Okay, so as you can see here, both the random variables are same, identical. Okay, and also they have said that they are identically distributed and they are independent, right? So whether you take whether you take this x1 here or x2 here, right? Okay, whether you change the sequence, whether you ask probability of x1 greater than x2 or probability of x2 greater than x1, right? The probability is going to be same for both. Okay, because they are, after all, they are what they are, the identical and independently distributed random variables, right? So in this case you can use the concept of probability. You can avoid no, avoid double integration avoid double integration. Don't use double integration to calculate this. So because here you can use double integration, right? You can say this is dx1 dx2, and you can easily solve. You can find the limit of integration for x1 and for x2 as well, right? And you can do, but we will not use this concept. Okay, we will not use the we will not calculate the double integration. We are going to employ the symmetry. So symmetry, by symmetry, what will be the answer here? By symmetry. So as they are asking that probability of x1 greater than x2, right, is same as probability of x2 greater than x1. This we know already. We can see, okay, from this okay, from region of support, you change, just you have to change the sequence, right? Probability for both condition, for both region of support, that is x1 greater than x2 or x2 greater than x1, is going to be similar or same, you can say, right? So what you can do here is, that total probability should be 1, right? So if you just add these two probabilities, right? So the total probability should be x1 greater than x2 plus x2 greater than x1 equal to 1, right? From the symmetry, what you have got here is, from the symmetry you have got these two are same because of IID, identical independent distribution. Okay, so here where you can employ symmetry concept, when two random variables are what, identical and independent. If they are not independent, then you can't use symmetry concept, right? Because you think about it, right? uh, at this moment I have considered two random variable. In future, in your exam, they can give you three random variable, four random variable, five random variable, many random variables, right? Then what you will do, you have to use the symmetric concept. You can't use double integral, triple integral. I mean, you can use, but that will take a lot of time. So what we, an engineer, right, what we do always is we try to find some of the you know concepts, right, which can reduce the number of steps while solving the problem. Okay, so you see here, if you add these, okay, so you know that the probability of this and the probability of this is going to be same. You can say p. So just you can put p plus p is equal to 1. 2p is going to be 1, so your answer will be 1 by 2. This is the answer. Okay, so by employing symmetric concepts, you are able to get the answer very quickly, right? You're able to get the answer very quick. I hope this concept is understood. So this is a region of support. By looking at region of support, if you want to find probability of this, okay, or area of this, what is probability here? Probability is basically the area, right? Probability here is probability meaning here is what, the area. Okay, few people solve these kind of a question by going with the help of some convolution, right, as well. Because if you are adding two random variables, so the density function is going to be what, the convolution of the individual density function, right? But that will again take couple of steps. But if you employ the symmetry concept, right, in fact you will not take know, much time. Okay, you will not take much time. You would be able to solve any question just by looking at the question, right? Let's take three random variable. This is for two random variable, right? So for both of question is probability of x1 greater than x2 will be half, probability of x2 greater than x1 will be half, right? From the symmetry we have done. Let's take one more question. Okay, so question here is I mean, if they are asking that if you have been given x1, x2, and x3, they are IID. IID means identical, independent, and identical, independent distribution, right? And they are uniformly distributed. You can say they are distributed that is 0 and 1. So needless to draw now the region of support, right? I mean, just think about the question is like this: probability of x1 being largest, probability of x1 being largest. What is the probability of x1 being largest? In this case, one more point I want to highlight here is one more point I want to highlight. Okay. In this case, one point I have no, I did not discuss about that, and that is obvious. Okay, if they will ask you, they will ask you, and these random variables are continuous random variable, right? If they will ask you what is the probability that x1 is equal to x, that should be directly 0. Okay, you can directly put, if you find anywhere the equality sign, equality, the probability for continuous random variable is going to be always 0. Okay, keep in mind this. So what I have done here is it should be like this: plus probability of x1 is equal to x2 should be equal to 1, right? Total probability from the symmetry, we have got that probability x1 greater than x2 and the probability x2 greater than x1. If you just flip the sequence, that's it. Your distribution would same. Your distribution would be same. Okay. Your probability, your region of support is gonna be same, right? For both the case. And if you see here for the, as we know the concept, okay, if anywhere the quality sign you find, so for that the probability should be equal to 0, right? For this you can say this is going to be 0 and your answer will be probability is equal to 1 by 2, right? Okay, so total probability means what? Total probability is probability of x1 greater than x2, probability of x2 greater than x1, plus probability of x1 is equal to x2 is equal to 1. And we know that for continuous random variable, if you try to find the probability of any region of support like x1 is equal to x2 for equality, okay, your two random variables are same and you're trying to find the probability of x1 equal to x2, so the probability is going to be 0. So keep this in mind. This is very important concept, right? Sometimes they might ask question and you might get digressed, right? Because you are not you feel like that random variable is so tough, but you can see if you use the intuition, okay, if you see some symmetry somewhere, always go for that. That makes your life more easy. So this kind of question is asked like x1, x2, x3. There are three random variables, right? Three random variables. They might ask you for four random variables. So always see the pattern, right? And they are IID. They are IID means independent identical distribution. They are same. All three random variables are same. They have same distribution. They are independent. Okay. So if they are asking probability of x1 being largest, okay, x1 is largest. So what are the possibility you can have, right? What are the possibilities you can have? There are three random variables, right? Possibilities. What are the possibility you can have? You are asking that x1 should be greater than x2, be greater than x. I mean x1 should be largest. So x1 is greater than x2, x2 is greater than x3, right? Okay, so x2 is greater than x1 is greater than x3. You can say that x3 is greater than x1 is greater than. You can say x3 is greater than x1. I mean x2 greater than x. You can say that x1 is greater than x3 is greater than x. You can say x1 is greater than x3 greater than x. I mean you can put here 2 and here you can. I hope this makes sense, right? So these are the few possibilities. Okay, you will also find some possibilities like x1 is greater. I mean x1 is equal to x2 is greater than x3, right? Like this. See, so probability for that will be always zero, remember, right? So these are the possibilities out of all possibilities, because if any possibility is having equal sign, okay, for that the probability will be zero, right? You know that here three random variables are what? IID, identical, independent, okay, identical independent distribution is given, right? So if you change the sequence, right, they are asking just the x1 is largest, right? So how many possibilities are there? So x1 is largest here and x1 is largest here, okay. Out of six possibilities there are only two possibilities, okay, which are correct according to this, okay. For that you have to find the probability, right? So these are the inequalities, okay, these are the inequalities. For that the probability will exist, but for this the probability will be zero, okay. So you will find many cases, many possibilities where where equality sign will be there. So again you can employ the symmetry concept, right? From the symmetry what you can say that probability of anything, probability of this, probability of this, probability of this, probability of this, probability of this will be what? 1 by 6. For this 1 by 6, okay. For this 1 by 6, 1 by 6, 1 by 6 by 6. But what they are asking is they are asking probability of x1 being largest. You can say that 1 by x plus 1 by x. It is going to be 2 by 6. 1 by 6, I mean, not x. 1 by 6 plus 1 by 6 is equal to 2 by 6. That is 1 by 3. So answer will be 1 by 3. Correct? The answer will be 1 by 3. Okay. Understand? So yes. You can see here, probability is going to be 1 by 6 plus 1 by 6, that is 2 by 3. So always go for some symmetry concepts, right? Always go for some symmetry concepts. So you will find the problem very easy, right? So, and if they are asking like this, remember always, they will ask you that what is the probability that x1 is equal to x2 greater than x3? So it is going to be zero always. Needless to solve anything. Somewhere, okay, somewhere there is some inequalities or sorry equalities, okay. For inequality you have to find the probability. For for equality you have to directly put the zero. For inequality, okay, the possibility which is having some inequality, you have to use the symmetry concept. Okay, I hope this makes sense for you. So yeah, so let me take one problem here, because this problem was asked in gate 014, right? Similar problem from the concept, okay. So here you can see there are three random variables x1, x2 and x3 with the independent identically distributed random variables, okay, with a uniform distribution 0 and 1. With a uniform distribution 0 and 1, right? Okay. This problem can be done within fraction of second, okay, because if you know the concept you can solve the question, okay. So you have to employ what? The symmetry concept. So as we know that there are x1, x2, they are IID. Okay, so they are asking probability of x1 is the largest one, right? So you know that you have to just add, okay, add all the possibilities, right? So you will get, out of six possibilities, okay, you have to find probability of x1 largest, going to be 2 by 6. That is, or you can say 1 by 6 plus 1 by 6. 1 by 6 plus 1 by 6, that is by 3. If there are 4 random variables, so you will get that 1 by 4 will be the answer. So this is how we use always the symmetry concept, right? Symmetry. Understand? They might ask one more question from this. They might ask you that what is the probability that x1 is in the middle? What is the probability that x1 is in the middle? Probability that x1 is in the middle. So you can see x1 is in the middle only two times. Okay, only two possibilities are there. So again 1 by 6 plus 1 by 6, that is 2 by 6, 1 by 3. Whatever you ask, answer will be 1 by 3 only. Okay. They might ask you x2 being largest. They might ask you x3 being largest, right? So answer will be what? 1 by 3. So first of all, you have to identify where you can employ symmetry. So you are able to find the probability of these possibilities, right? For one possibility, probability is going to be 1 by 6. So because there are 6 possibilities, so for 1 by 6. So always go for symmetry concepts. We'll take one more session on symmetry after this, right? Because I think some internet problem is happening, right? So okay, so please go for that, right? In gate 2014 this kind of question was asked, but you must know before solving this question. There are various concepts which involve symmetry. Symmetry can be only used when your random variable is identically distributed as well as independent, right? Then only you can use symmetry. You can get this kind of a question as well in future. And if they will ask you what is the probability that the x1 is smallest, right? There are three random variables. Take that also. x1, x2, x3, x4. Suppose this kind of a question is there. They are IID and they are asking probability of x1 is smallest among all, right? What can be the probability here? So there are four, right? In our case there was six. Okay, I mean three random variables, so we got six possibilities, and which were having inequality sign. For that the probability will exist, right? But if any possibilities are there, okay, or any, you can say the regional supports are there which are having equality sign, so that is because you might find some random, because random variables are same here, right? Yeah, so here x1 is smallest. What is the meaning that you can say x1 is far less than x2, far less than x3, far less than, so here x4 is greater. So you can say that x1 is, so now what, this should be fixed now, right? You have to fill this. So you can fill this in how many ways? X2 you can put, x3 you can put, whatever you want to put, right? Okay, you have got what you can use the, you can use also some permutation concept as well. Okay, suppose there are four blocks, this is fixed, right? Okay, this can be filled in, okay, in only one ways, right? But how many ways these three block can be filled in? There are three. Okay, so three, right? Okay, so how many possibilities you can have? There will be many possibilities, right? If you are putting x2 here, so you're putting, so here x3 x4 will be there, right? Okay, so you can use that concept as well, right? There are four random variables, so you can say this will be what, this will be 1 by 4 will be the answer for this question. From the symmetry I'm solving directly. You will also find in the problem that there are few region of support where x1 is equal to x2, okay, or less than something. So always go for symmetry. You will be always be happy to get the answer. Don't have to draw. Now you can take n number of random variable. If they are IID, so symmetry concept is applicable. So we will meet in the next session and we will talk more important concept, okay, related to Okay, symmetry. We'll solve some expectation problem using symmetry to avoid integration. Thank you.